Hi, do you want to do an experiment with me? All right, here's what I want you to do. I want you to take these two metal balls, I want you to hold them above these tubes, and then I want you to let go on 3. 1, 2, 3. Wow, yeah, this one on the right was really bouncy. Well, let's talk about why that happened. So first, let's take a look at these two metal bases and see if we notice any differences. Yeah, so this one on the right has a little disc, an extra disc on top of it. So this is what's called an amorphous metal, or a metallic glass. And so I want to talk to you about that. But first, let's talk about this one on your left. This is regular steel, which is a crystalline material. So most metallic materials that you come into contact with in your everyday life are crystalline materials. And so that means that the atoms have a very nice, orderly structure to them. This material here on your right is an amorphous metal, or a metallic glass. And that means that the atoms are kind of more randomly arranged. There's no set pattern to how they're formed. So let's take a look at this. If you look down this tube, you'll see that there are some pock marks. There's some little divots in here. So what's happening in that crystalline steel is as the ball hits the surface, it's able to push atoms in the metal out of its way. And those atoms are able to slide past each other in what we call a slip plane. Whereas on the right with that metallic glass, the atoms are kind of all over the place, and there's no real way that they can move. And so we call this atomic gridlock. So a couple things that you may have seen, you might be familiar with. You may have seen glasses such as this. So these types of glasses are made out of silicon and oxygen. And so the atoms are kind of arranged in a random pattern. Whereas in quartz is also made out of silicon and oxygen, but the atoms do form a nice pattern, and that makes glass and quartz have very different properties. And you've probably also seen something like these. So this is, for sugars, rock candy is a crystalline form of sugar, and a lifesaver is an amorphous form of sugar. So these types of metallic glasses have a lot of really cool applications. So you can use them for surgical instruments that would be extremely strong and difficult to break and wear down. You could put them on industrial coatings for drill bits, or for applications where you need something that's very strong. NASA has used metallic glasses in some of their spaceflight missions, and the military uses metallic glasses for some armor-piercing bullets. Another application is with these golf clubs. So if you wanted to have a nice long drive, you could put a metallic glass onto your golf club head, and that would make that golf ball go really, really far. And these golf club heads are actually so good at doing their job that these metallic glass coated heads are illegal in tournament play. Too much of a competitive advantage. All right, so now let's talk about how we actually make a metallic glass. So here I have a speaker, and on the speaker I have these little metal beads. These metal beads are going to represent the atoms in our material. What I'm going to do is I'm going to turn the speaker on, and the speaker is going to vibrate, and as it vibrates, that's going to be, the more vibrations, the more temperature it has. So we're going to heat it up, get these balls bouncing, and that's going to be our liquid state. And then as I turn the speaker off, it's going to be the equivalent of cooling the material down. So we're going to put it back into a solid state. So let me get this speaker going. So this is our liquid state. So now you can see that these atoms have formed a really nice hexagonal pattern. So this is a crystal that we've just made. So now let's try this again and see if we can make a glass. So again, I'm going to turn the speaker on. It's It's going to get those balls bouncing around. That's going to be our liquid state. And then I'm going to try and cut the temperature really fast in a process called quenching. And now you can see that there's gaps, there's holes, there's no real set continuing pattern to this material. This is how we make a metallic glass. So let me know if you have any other questions. I'd be happy to answer them. Or you can go to our website, education.mersec.wisc.edu, to learn more.